Bristol Community College, Mathematics with Dan Avedikian, Math 060, Topics in Developmental Mathematics, Section 2.8, Problem 13. This is Section 2.8, Problem number 13. It says complete the computation, and we have 13 over 20 plus 11 over 50. So to add these fractions, what we need to do is make the denominators the same. We have to find the common denominator. So let's start by writing them in a vertical format. So let me write 13 over 20, and a little below it I'll write 11 over 50. And it's an addition, so we keep it in addition. So I'll put a line and a plus sign. Now, when my denominators don't match, one explanation is to find the LCM for the two, do the prime factorization, and that will work, and it works good, works every time, but it's more tedious in my opinion than it needs to be. I look at the large denominator, 50. Ask myself, will the smaller denominator of 20 divide into it evenly? It won't. So take the bigger one, double it. And if that doesn't work, then you triple it, quadruple it, times 5, etc. But if I double the 50, I get 100. Will 20 divide into 100 evenly? Sure, it goes in evenly. It goes in 5 times. So 100 makes for a very good common denominator. So next to each fraction, I'll write an equivalent fraction, and that equivalent fraction will have a denominator of 100. Now again, there are other denominators that'll work, like say 1,000 as a common denominator, but you want to keep it as low as you can, smallest common denominator. Now, let me fill in the numerators for those fractions that will keep them equivalent. So if I look at the upper fraction with a denominator of 20, 20 times some value turned into a 100. That some value must be a 5. 20 times 5 is 100. So the numerator is multiplied times that same value, in this case times 5. 13 times 5. Now I know that should be 65. Let's say you're not really sure. Burn up the 2 or 3 seconds it's going to take to go off to the side and just multiply 13 times 5. 5 times 3 is 15, write the 5, carry the 1, then 5 times 1 is 5, plus the 1 more that you carried, 5 plus 1 more is 6. There's your 65. You can verify it if you're not totally sure. Then, for the other fraction, the 11 over 50 equals something over 100. Well, the denominator of 50 times something turned it into a 100. That something must be times 2. So the numerator gets multiplied times the same amount. In this problem, times 2. So the numerator of 11 times 2 is 22. 11 times 2 is 22. Now, I have two fractions that have the same denominator. I'm going to add these up again because it's an addition. So the denominator stays whatever my common denominator is, in this case 100, and I can combine the numerators. So I'm going to combine 65 plus 22 more. So again, looking at it, I can see it's an 87. Let's say you don't, just take it one column at a time. 5 and 2 more is 7, nothing to carry, and then 6 plus 2 more is 8. So I get a final answer of 87 over 100. You should check to see if it can be reduced. Are there any values to divide it into 87 and 100 evenly for both? And you can try 2, 3, 5, few things, and you'll see that nothing divides into both evenly. So that's as reduced as it can get. So 87 over 100 is our final answer.